Hi everyone, I hope you're having a great day and I hope you're excited and ready for your first video recorded lesson. Please turn to page 14. Looks just like what you see on the screen. Feel free to pause this video at any time if you need time to catch up, reread something, or try something on your own. Also feel free to rewind if you want to rewatch something. The essential question for this page is, how is an irrational number different from a rational number? Not sure if you've heard those words before, but they are big buzzwords in this lesson and in this topic. Example number 1, identify irrational numbers. The Venn diagram shows the relationships among rational numbers. How would you classify the number 0.24758326? So as you can see over here, we have different groupings of numbers. The biggest grouping is of rational numbers, and they're numbers like -4/5, 0.75, 31.8. Then it moves into integers, whole numbers, and natural numbers. So this decimal does not terminate, which means it doesn't end. So feel free to write there. Terminate means end. Or repeat. So a repeating number would be the same numbers happening over and over again. Since it does not terminate or repeat, it is irrational. It is not a rational number. Numbers that are not rational are called irrational. An irrational number is a number that cannot be written down in the form a over b, where a and b are integers. So otherwise, it cannot be written as a fraction. So make sure you take note of this irrational number, the definition, because that will be on your test. So let's try it. Classify each number as rational or irrational. Feel free to pause it and work on this on your own, and I will show you the answer when you're done. So, if you didn't pause it and you're just trying to watch it through, that's great. If you did pause it, just follow along and check your answers. First, the number pi. Pi is equal to 3.141592654, and goes on forever and ever and ever. There are no repeating decimals, and it also doesn't end. So pi is irrational. Then the next number, 0.04053661, again, goes on forever, and it does not repeat, so it is irrational. 0.4053661. Next number, 0.76 with the bar above it. That bar above means that the numbers repeat. So, since it is repeating, that means it is a rational number. So we're going to put 0.76 under the rational. Then 3.565565556, this number right here. You might think that it's repeating because it's the same numbers happening over and over again, but it is not in a specific repeating pattern. Each time the fives get more. So it is not repeating, meaning it is irrational. And it does not terminate. -17. -17 is just -17. It ends there. It terminates. Since it terminates, that is a rational number. 3.275. It doesn't repeat, but it does end at just 5. There are no ... dots after, so that is rational. Check your work. I hope you got it right. Jen classifies the number 4.567 as irrational because it does not repeat. Is Jen correct? This number 4.567, she's right that it doesn't repeat, but it does what? It ends. So 4.567 ends right at 7. So Jen is not correct because it terminates. Let's get in the habit of saying terminates. No, because it terminates. A terminating number is rational. Let's move on to the next page. Example number 2. Classify the square root of 3. Square root of 3. That little symbol there looks like this. Looks like a little house, I like to call it. Means the square root. Here is another one of your vocab words that you are going to need for the test. The square root of a number is a number that when multiplied by itself equals the original number. The radical symbol, that's this little house, is used to denote the non-negative square root. So here they're showing examples of square root. Since 1 times 1 equals 1, the square root of 1 is 1. Here's a more concrete example. 2 times 2 equals 4. So the opposite way means the square root of 4 is equal to 2. And one more time, 3 times 3 is 9. So going back the other way, the square root of 9 is 3. All these numbers that come out to perfect integers, the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Since they come out to perfect integers, they are called perfect squares. Again, here is another one of your vocab words. A perfect square is a number that is the square of an integer. The first 3 integer perfect squares are 1, 4, and 9. So that helps us show that square roots could be rational or irrational. But since the square root of 3 does not equal an integer, a number that stops, or as we're saying, terminates, let's see in our calculators, it'll actually show us what the square root of 3 is. Now, the square root of 3, I hope you looked in your calculator because I did too. The square root of 3 is equal to 1.732050807, goes on and on and on. I see no repeating numbers and it does not terminate, therefore it is irrational. I like to think of irrational and rational as like I've heard people be described as irrational. That means they're crazy all over the place. And I think of repeating numbers and numbers that end as kind of like sane and put together. So, example number 3, classify each number as rational or irrational and explain how you classified each number. So we'll start with this, negative 81,572. So it says it's an integer, and it can be written as a fraction, so it is rational. This number also terminates. Remember that word that means ends. Terminates. Next, the square root of 11. The square root of 11 is not a perfect square, so square root of 11 is irrational. Again, if we check in our calculator, the square root of 11 ends up being equal to 3.316624, on and on. It does not end, and it does not repeat. Therefore, it is irrational. Looking at the next number, 5.633. We've seen an example like this before. It does not repeat or terminate. It goes on forever, and there's not a repeating pattern. Last but not least, the square root of 16. The number 16 is a perfect square because the square root of 16 is 4. Therefore, it is a rational number because 4 times 4 equals 16. The last try I'm going to leave up to you. So please pause the video and try it by yourself. Then when you are done pausing the video, when you are done classifying each as rational or irrational, unpause the video and follow along with me and make sure you got the answers correct. Okay, welcome back. 2/3. If we were to put 2 divided by 3 in our calculator, we would come up with 0.66666 repeating. This number is rational, and it is rational because it repeats. The square root of 25 is equal to 5 because 5 times 5 equals 25. 5 is a rational number because it terminates. Next, negative 0.75 repeating. Well, there you have it. It's rational because it repeats. The square root of 2. Well, let's double check in our calculator. What is the square root of 2? The square root of 2 is equal to 1.41421356, on and on. So since it keeps going, it does not terminate, and I do not see repeating, so it is irrational because it does not terminate. So no terminate and no repeat. Last but not least, we've got 7,548,123. It is a rational number. It terminates. It ends right there at the 3. All right, great job, guys. Thank you for watching the lesson. If you need help with your homework, feel free to go back and rewatch the lesson. And I hope you enjoyed.